Okay, hi everyone. In this week's lecture, we're going to look at the topic of AI and alignment. You can see on the screen that I've put another kind of classical, very well-known, almost cliched image. In this case, again, coming from the European Christian tradition, we have a representation by Michelangelo of God and his creation Adam. And as I described in the week on science fiction, this preoccupation that we have in many cultural traditions of the creator and their responsibility for their creations, I think is a really good frame for talking about the subject of AI and alignment. So we can think about AI as a very fast automated decision-making machine. There are lots of reasons why this could be very, very useful, from healthcare to transportation, finance, climate solutions, war and conflict resolution, and so on. But there's plenty of examples of technology that goes wrong. Let's start with one from my own country, from Australia. What we see on the screen here is a cane toad. At the beginning of the 20th century, sugar was being grown all throughout the state of Queensland in sort of the northeast of Australia. Problem is that there were little beetles that were eating the sugarcane plants. In Latin America and in Puerto Rico, there was a toad that was successfully eating the beetles. So the decision was made in the 1930s to bring the cane toad to Australia to see if it could eat the cane beetles and therefore preserve the sugar crops. Well, what ended up happening is that because the cane toad is poisonous, therefore anything that would usually eat frogs cannot eat the toad basically bred and spread. And if you look at this time lapse down here, you'll see that over the decades since it's been introduced, there are now, I think, something like 200 million cane toads in Australia. And for perspective, there's 25 million people in Australia. So what you can see here is what sounds like a perfectly logical technological decision, but it occurs, one, in a complex system, and two, with an exponential scale dynamic, where in this case, the reproductive cycle of the frogs without any predators led to the frogs becoming a much larger problem than the sugarcane beetles were in the first place. So this type of thinking is what's behind one of the most famous examples of AI alignment. And this is the paperclip maximizer experiment designed by philosopher Nick Bostrom. The paperclip maximizer is a thought experiment where we imagine an AI system designed with a very simple goal: to make as many paperclips as possible. Paperclips, no problem. What could go wrong with paperclips? Well, if we think about it, the AI could optimize every possible area. It could convert every single resource available into paperclips, including human habitats, humans, trees, buildings, mountains, everything turned into paperclips. This problem could arise because if the AI is very tightly focused on its programmed objective, it wouldn't understand the complexity of human values or limitations. There would be reasons that we wouldn't want to convert every human being into a paperclip. Bostrom uses this scenario to emphasize the fact that creating technological solutions in AI that have the exponential ability to scale is inherently risky if we don't understand the complexity and the different directions that a simple goal might transform into with exponential increase in scale. There's a video here. I'll just mute it. I'll encourage you to watch. We'll provide a link in the course materials. And this is a great sort of short film based on the paperclip maximizer. So the paperclip maximizer is engaging with something we called Goodhart's law. And what I'm going to do in the next few slides is introduce Goodhart's law and a few others that are examples of specific challenges in AI alignment, and also some examples of how these challenges are currently being mitigated by computer scientists. So in the case of the paperclip maximizer, Goodhart would say when an AI optimizes for a metric, it might over-focus on the metric to the detriment of the broader human goal. For example, if we tell an AI to maximize paperclip production, it will turn the entire world into a paperclip factory. And we could say that this AI is unaligned because it is now out of alignment with the general scope of human values. If we look at another example of AI alignment, we can look at the problem of instrumental convergence, where a powerful AI might develop sub-goals in order to achieve its programmed objective that also might conflict with human values. If we imagine a trading algorithm AI system where we want an AI that can automatically generate great returns through automatic trading, the system might decide that financial regulations are an impediment to its goal of maximizing returns. So therefore it might break financial regulations, or it might seek to change financial regulations via manipulating regulators by starting to lobby the financial industry to achieve its own goals. It might develop unhealthy competitive practices. There are many things it could do in order to achieve its goal, and an unaligned AI in this case would be one where these sub-goals conflict with human values. One of the complexities here, if we think of AI alignment as a misalignment between the actions of an AI and human values, is that human values themselves are not always very clear. For example, think about something like surveillance. In many countries across the world, surveillance cameras have been installed ostensibly to reduce crime. For example, are you less likely to get robbed on the street if that robbery would be captured on camera and the person committing the crime could be more easily caught by law enforcement? Attitudes to this obviously are very different all over the world. And I found this article here which presents a very clear case where most of us probably would not want any surveillance, a toilet in a school, right? So where in some cases people seemed quite happy with levels of surveillance from a camera that monitors your baby while it's sleeping, or a camera that monitors your dog, or a camera that monitors your business, a camera that monitors you while you're on the toilet, it seems to break some human ethical line. And there are so many examples of this where it's not necessarily clear exactly what human values are, and therefore programming them into an AI explicitly can be incredibly difficult. So how are people trying to get around this? Reward modeling is one example. So imagine we're training a household robot to clean efficiently. The robot could receive positive rewards for cleaning up messes quickly, and it could receive some sort of penalty for breaking items, or in this case, for accidentally trying to clean the dog's tail, and so on. Even reward modeling presents challenges. The reward function must accurately capture aspects of human preferences, whilst not rewarding things that might sound good, but might end up going away from human preferences. For example, the robot might prioritize cleaning more quickly over cleaning more careful, and so on and so on. And you can kind of see the delicate balance that reward modeling requires. Okay. Another example would be inverse reinforcement learning. So instead of telling the AI what to do, the AI watches what humans do, and instead of us telling it its values, it just watches us and sees what we do. So in the case of autonomous driving, we could say, okay, let's not give the AI all of the rules of the road. Let's just allow the AI to watch us drive, and it can infer from that how we behave. I've put this video on the screen here. I think it's quite interesting. If you look, we've got a hole in the road here, and some people slow down, some people go around it, some people in big, larger SUVs drive straight over it. So that also has a complexity to it. Deriving values from human behaviors will also involve observing the fact that different people in different situations will react with a different solution to the same problem. Every time somebody slows down, it creates a slight traffic block. If the person swerves onto the other lane, that could create danger for people on the inside lane, different types of cars, and so on and so on. So you can see that inverse reinforcement learning could actually capture quite a broad series of responses, but it also contains its own complexities. Okay, another strategy in AI alignment is coherent extrapolated volition, or CEV. The idea here is building AI systems that not only reflect current human values, but also try to improve upon them on time. Think of it like a kind of a social compass that points not just to where you are now, but to where you want to be. You know, if you had a compass that said this direction is sort of my direction towards a better life, you know, you'd use it to guide your decisions. Obviously, the challenge there is a challenge that's been explored in political science and literature for hundreds of years. What does a better society look like? Is a better society simply optimizing functions of our society now? Or is it something in the utopian genre where we imagine a perfect society that seems to cure all the problems we have today? The book I have on the screen here, Utopia, by Thomas More, is a very famous example. It's the first time this word was used. Thomas More's Utopia imagines a perfect society, but in many ways, the perfect society imagined by Thomas More is really only logical in relation to Tudor England in the 16th century when More wrote the book. And a lot of the solutions presented in Utopia are really, in a sense, critiques based on the political situation that Thomas More was living in at the time. And if we look on the right-hand side, we can observe a similar feature. The destruction of World War II led to a huge rebuilding project in many European cities in the 1950s and 60s, and it led to a new vision of what housing should look like. The type of housing that was built at that time had definitely a utopian character, but looking back many decades later, people can see both problems and solutions that arose from the particular design of high-density housing. Another sort of strategy we can look at in AI alignment is scalable oversight, or teaching AI systems to ask for human input when they're not sure. So, for example, this could be incredibly useful in medical diagnoses. An AI system could perhaps more efficiently search for a correlation between the symptoms that a patient reports and the different conditions it would be. And technically, they should be able to do that larger than a person. And this could lead to faster medical diagnosis. But on the other hand, as the AI becomes larger and analyzes millions of cases across different hospitals, direct human oversight might become impractical. There might not be enough humans to sort of oversee. So we would need other techniques like delegation or automated checking. And we could still end up in a situation where an AI that is trained to ask for help or clarification could still, when making independent decisions, still end up making incorrect decisions. And we would have to face the ethical issue of, do we agree with less incorrect decisions, but the incorrect decisions coming from autonomous systems, or would we be more comfortable with the human error that we have lived with for much longer? You can imagine the same thing in autonomous driving. We tend to focus more on the strangeness of the accidents that happen with autonomous vehicles, even though statistically they're probably becoming less accident prone than humans, but there's something disturbing to us about the mistakes that are made by an autonomous system, even if they are fewer. Okay, and finally, another strategy that would be added on top of these would be something like debate and interpretability. So building AI systems that can explain their decisions and can debate their reasoning both with one another and also in how they present this reasoning to the human who's using the system. So you'll see this increasingly now in the past, I guess, 6 months with reasoning models that explain their decision making. And this can be a way to, I suppose, help the human user judge whether the decision that's been recommended or the information given by the AI has a kind of logical basis by trying to see the reasoning behind the decision. Okay, so to me, all of these questions in AI and alignment, what's so interesting about them, much like their basis in philosophy and literature, is that they're constantly being debated. I've listed a few people here who over the past 5 years or so have been very, very vocal in making quite different arguments relating to AI risk. Eliezer Yudkowsky, a very, very prominent thinker in the AI space, has been warning for many years that AI poses an existential threat to humanity. Mark Andreessen, also very prominent in the AI space, a tech founder, has referred to AI as a digital renaissance, a new flourishing of creativity, economic growth, betterment of human life, and so on. Elon Musk famously founded OpenAI because he believed that Google's values were becoming unaligned with a broader human good. And in all of these cases, we'll see constantly a revising of people's optimistic or pessimistic perspectives. There are a lot of these people have been giving interviews online. You can find them quite easily. There's many of them.
The problem is,
the final slide I wanted to put is one that I came across earlier this year. These are a couple of examples. Chen Fun's AI 2041 and AI 2027, which is another sort of, I guess, like science fiction prediction of what goes wrong if AI alignment fails. So if you're interested in this topic, I highly recommend listening to interviews with various thinkers in these fields. Read one of these books. I think this one here on the right you can actually listen to on your phone, and I think you'll get a great understanding of how alignment is playing out at the exact same time that these technologies are becoming a very prominent part of our lives. Okay, I'll see you in the next lecture.